Yeah, okay. Thank you for joining the seminar. We want to talk today about the new ANSI CTA-709.8 Advanced High-Speed Powerline Communication Topology, which is called HD-PLC. We started that process already 2017, so it's 3 years ago, more or less 2.5, to address upcoming requirements in smart cities and buildings. So it's not only building, it's the outside of the building too. And we are happy that we can announce that 709.8 is now approved by CTA. We had the press release a few days ago out, and additionally, we have to thank all the Landmark members for their diligent efforts working in the task groups to get that a standard here in the US and in parallel in Europe too. Well, you see, that's not me. It was planned that we do that presentation together, Michael and I. Michael is from Megachips. He is working there as vice president in sales. Since 30 years, he is in the high-tech area, especially semiconductors working. Unfortunately, he is sick and he was not able to join the show. He is working at Megachips. This is a fabless semiconductor company in Japan with something around 900 employees and up to $1 billion in sales, not only in Powerline, but they are selling timing chips, HDMI chips, and all of that. Michael, he served as a board member for various PLC associations, and he was one of the founders of the G3 PLC association. Nowadays, he is working mainly in the PLC for automation and multimedia sectors. That's our agenda for today, and you see I have to read a little bit because Michael provided me with his notes. So that's the agenda. We will start with an HD-PLC overview, a technological overview, so that you know what we are talking about. Well, with the proliferation of IoT devices and as the networks become bigger and bigger, the security concern grows and there's a greater flow of information through the cloud, and we need higher bandwidth, higher security, the ability for a larger number of nodes and long-range communication. This is more and more apparent. For that, we need a new communication method. The method is it has not only to meet the application requirements, but it additionally has to address the cost of implementation. And this is especially true in larger smart city applications such as smart grids, building automation, connected with street and public lighting, smart homes, security and surveillance, and many other. You can have a look at the slide, what we have there as different applications. We have many choices together today to get some systems integrated, highly complex wireless networks, 2G, 3G, 4G, LoRa, Sigfox, Zigbee, all of that, and very costly wire installations such as Ethernet and fiber. When we have a look at the problem with the notes, apologies for that. But when we look at all of the key system requirements from an end application point of view, and when we are deciding which technology best fits to their requirements, one technology that stands out is Broadband PLC, so not Narrowband PLC, which is the closest in meeting all the requirements of the end customers. I want to give you a quick overview on what we are doing in advancing the communication and network technology within the automation markets and why. I will touch base on some of the market requirements and challenges and our proposed solution and its advantages. I will give you a quick overview on an advanced broadband technology called HD-PLC and its specification and our activities within Landmark International. We have been approached by many major customers, and what they tell us is, while they like to stay with their current protocol and tools, BACnet, LON, KNX, more in Europe, they are dissatisfied with the bandwidth limitation, not being IP-based and low security. They believe it no longer supports the new requirements for IoT. They asked to come up with a solution to address these issues. So here's what we are offering as an alternative. If you have been in this space for a while, you already know that existing communications technology requires difficult trades-off. With serials such as RS-485, you get longer ranges, but you have to sacrifice speed and are limited in the number of nodes you can deploy, among other limitations. Wireless holds the promise of easier deployment, but range is an issue. Also, security is a concern. Of course, Narrowband PLC offers the lowest deployment cost, but with narrowband solutions, you are limited to kilobit speeds. Ethernet is being tried by several companies, but the cost of installing new wiring keeps many projects getting off the drawing board. How is that possible, what we see? Let me back up and review some of the key characteristics between various wireline technologies in use today and how HD-PLC stacks up against them. The x-axis shows the operation frequency for some of the most popular wireline communication technologies, and the y-axis shows the relevant range. I didn't put any numbers on the range as it varies depending on the line conditions, such as the type of cables, the type of delivery devices on the line, number of branches, noise on the line, and so on. We'll talk about that some more on the next slide. So here, the lower the frequency band, the longer your transmission is. As an example, RS-485 on this chart operates at 9.6 kilobaud, having the longest range, versus Ethernet operating at above 125 megahertz with the shortest range, about 250 meters. Broadband PLC is in the middle of the road, operating in the range from 2 to 100 megahertz, dependent on the technology being used. There are several standards in use today developed for specific applications. There's HP developed for home plug, developed for some home networking, GHN for telecoms and last mile access, and HD-PLC for industrial. There are a couple of unique features for HD-PLC. One is its frequency band and the other its repeating function. We selected frequency band from 2 to 28 megahertz for optimum cost and performance. We found the higher frequency from 28 to 100 megahertz really doesn't add much more performance, while it makes the chip architecture more complex and more expensive. The other unique feature is its repeating function. It extends the communication range comparable to those of low frequency technologies and performance to those of higher frequencies. Here I'm showing other differences between the old narrowband PLC technology versus broadband and why broadband power line is more robust. In its noise level is lower in higher frequency. There are a couple of unique features for HD-PLC. One is its frequency band and the other is its repeating function. We selected the frequency for, that's the same, I'm repeating what I'm telling you. See, okay, sorry, let's skip the notes. Okay, that was it. Didn't work properly. Here I'm showing another difference between various wireline technologies in terms of range. Number of nodes, type of network supported, and so on. Please have a look at the chart. HD-PLC offers the best balance between cost and performance. It has the lowest deployment cost. I just want to refer that you see Ethernet, which is only a peer-to-peer communication, which has high speed, but it makes it very complicated to map large networks with hundreds or tens of Ethernet switches. So what's special about HD-PLC? For starters, it gives you a big performance upgrade from kilobits to megabits. So you can send bigger packets more often, reaching more nodes in larger network conditions. You get the plug-and-play simplicity and IP-based mesh networking. With HD-PLC, deployment is as easy as plugging in the devices and turning them on. And the biggest benefit is you get all of these capabilities without having to replace a single wire. Big performance advantages, lower deployment costs. It's a win-win for product engineers, system integrators, and project owners. These are the key specifications for HD-PLC and together with performance on 709.8. This technology was originally developed by Panasonic and later adopted by the IEEE 1901 standard in 2010. It is also approved by several other standard bodies worldwide, such as referred to the slide. So we go to China, Japan, and all of that. The HD-PLC Alliance acts as the certification body. They were established in 2007, founded by Panasonic and Megachips, as being the main chip provider for the technology in support of the Alliance. One of the biggest innovation in HD-PLC is the routing technique called CMSR, which stands for Centralized Matrix Source Routing. It is based on an ITU standard, and it was defined specifically for industrial networks where longer ranges, support for large number of nodes, and robust communication is required. It allows any node to act as a repeater. So that's the standard which is defining the mesh functionality we are using in 709.8. One of the features of this new standard is the ability to act as a bridge between the various communications technologies. Another it is ability to communicate over any wires, so not only power cable, but twisted pair, coax, all of that. What this means is you can use this solution to connect between networks and different devices. Also, you can use it as a redundant system over your existing network. So in tests, we run RS-485 in parallel with HD-PLC. We run LON on a twisted pair network in parallel with HD-PLC. So you can use it on the same wire. When I was making the graphics for the slide, I wanted to show the vast number of applications in the smart city, smart homes, cars, smart grids, factories, and buildings. You can see from the picture how all these segments are connected already through power lines. Then why not use the power line as a backbone technology or platform to communicate with each other? Today, broadband power line is adopted by the SAE for EV charging and billing. There are over 50 million units have shipped for home networking, mainly in Europe and Asia, and millions other for industrial applications. According to OWIM's smart home forecast, the number of households with installed smart home devices will grow by 60% over the next 5 years, totaling 500 million households and an installed base of 7.7 billion devices. Over the same period, revenue from device sales and smart home services will grow by 45%, totaling around $153 billion, making it one of the fastest growing markets in the TMT sector. Chips and products are available in the market today. So we have routers for the different Fieldbus technologies, chips, we have devices, everything you need is present, and we are working on real controllers. We have comprehensive tools for design, implementation, test, and troubleshooting. We can show the topology of the network, lists, carrier to interference plus noise ratio levels, and this is giving you a good look on the quality of your network. So each device can act as an analyzer device. Here are some existing samples where you find HD-PLC already in HVAC components, smart lighting, security systems. All of that can be done using HD-PLC and is available in the market. Okay, now that's me. Well, I'm Gesitec's CTO since around 10 years now, and I'm with Lawnworks Familiar since more or less 25 years. I'm in the Lombard International Board since 4 years, I think. And yeah, I started at my company development with HD-PLC. I will add some information about, that's interesting. Let's see. Yeah, okay, this is how it works. The other parts of the agenda, and as the technology is now already used in the market, there may be some questions. What happens, or how does an installation with HD-PLC work? I have a small device with me, so of course we start with wiring. That's pretty simple. We have to connect the wires to the module. Later we will see there's a master functionality. There's a pretty tiny dip switch that prevents it from accidental putting it in the wrong direction. And that gives us the opportunity. At first you have to wire power, Ethernet, and if you use the RS-485, you have to connect the RS-485. So that's a no-brainer. Next one is we have to address security settings if we want. So normally you should do that. Each device we select here between master and terminals, it will have a MAC address like any other Ethernet device. And the first security means is we can do something like a whitelist on the master, so the master knows all the other devices which are allowed to go to the network. That's the first method we can do. The next is all the terminals, the clients, can have a MAC address of the master, so they know to which master they are allowed to connect. And the third one is each device will own a shared key, which needs to be the same for all devices on the network. But you see the top on the right, this guy is different, and this one is not allowed to play with the others. So this is how we are addressing security. Next we can do our extended functions like selecting the functionality, port rate for the RS-485 port. If we need to have it, an IP address, normally we don't use that. Is it a 709.8 Master? It is in the standard, it's always written control network protocol to be agnostic for some legal terms like LON. We can implement on that device a repeater from LON IP to HD-PLC and even more. It depends on the device, what you have as user settings. Next question is, what blocks us from use that technology on a piece of cable? As we have seen in the first slides, we are using a frequency range from 2 to 28 megahertz. So this needs to be conducted on the wire. So sometimes we want to block that from one cable to the other one. And then we can use a off-the-shelf EMC filter. 80 dB attenuation are sufficient to block completely the signal. That's the link budget we have in HD-PLC. But we have additionally unwanted blockers, which make the communication not possible or which prevents from a good communication. So the first one is we have different phases, of course. So it's a single phase communication. So if we have different phases, they cannot talk with each other. Well, in my company, all of the cables are in the duct, 3 phases, line by line, and crosstalk is already implementing a more or less sufficient communication between the phases. We have transformers. Transformer is like a big EMC filter. Normally it will have something about 40 to 50 dB attenuation, so it prevents us from working with that. We have circuit breakers. The circuit breaker normally has a small transducer inside, which is magnetic, and that is something about 20 dBs. So it can make some issues. And we have the residual current switches, and they, once again, they have a transformer inside to measure. The good news is, since we are using the same frequency range like home plug, we can use off-the-shelf products which solve the problem already for home plug, phase couplers. You can have simple capacitive phase couplers, but they introduce a small leak current between the phases. So you are not allowed to use that in case of jumping over a current breaker or in case of jumping over a meter, because if you use that to jump over a meter, it will change the metering results. For that case, we have in the market some combined phase couplers, which are both inductive and capacitive. So you need to take care on doing the electrical installation. And what we can do additionally is, this is a very simple and stupid HD-PLC device. It tunnels HD-PLC from Ethernet, tunnels Ethernet via HD-PLC. If you put a patch cable here inside, you can additionally jump over a gap. Next thing is we have a master in the network which is doing all of the routing calculation, and your concern will be, oh, that's a single point of failure in the network. So we have some means to do that. What happens if master A doesn't work anymore? Then can we define that what has been terminal B before acts now as a master? So we can set up a device that it takes automatically the role of the master when the initial master has vanished. That's the first thing we can do. The other is working in a dual master application. That depends on how we set up the whitelists. And once again, if the first master has died, now the terminals, now the terminals decide that they go to the backup master. So we can handle that single point of failure situation with implementing redundant masters. In designing an HD-PLC network, you need to keep that in mind. Each device we have is an analyzer. So with a Blue Chip Manager software from Megachips, you hook up your PC using Ethernet, and then you can see the device list, topology, performance of the network, the noise level, and you can additionally run using iPerf or JPerf, you can run performance tests on the network. And it looks like that. That was an office setup or lab setup we had with around 16 devices. This is a signal noise ratio. Additionally, it is showing the efficiency of the different frequency ranges and modulation levels. And this is from practice. This is a JPerf screenshot we did on a 1 kilometer aluminum cable in Poland on a test, which is running around 15 megabits per second on a kilometer cable. This is how it looks like. So this is really playing around in a big hall, rolling out a kilometer of aluminum cable, which has very poor high frequency capabilities. You see it is a meandering topology, so we had a lot of crosstalk. That puts us, oh, we have a kilometer of cable, but without any repeating. We had been surprised with a very good performance. So the next step was going, I had fun, you see. Next step was going outdoor. So we roll out that 1 kilometer cable somewhere out in the nowhere, working directly on the ground. At the end of the day, we have to wind it up again. And if you have that thick aluminum cable, so it's really better than a workout in the gym. Okay, these are the basics. How to install, what can happen in a network, how can the tools assist. And the next step is, how can we put a field bus on HD-PLC? Nobody in building automation likes the word field bus. In Lonmark, we don't like the word field bus. In BACnet, don't like the word field bus. Modbus is a field bus. At the end of the day, all people would expect what we are doing are field bus systems. So how is a device built up? We are using, at first, a CPU for running Powerline at all, and this CPU includes all. It includes RAM, it has a port for a tiny flash chip, it includes the HD-PLC, Mac, and PHY, it includes RS-485, and we just have to add, you see that on the right side, the Powerline coupler, which is dependent on what you do. Is it high voltage cable or is it maybe only a twisted pair? And in case of a 120 volt cable, it's only very simple and cheap transformer, which makes it the total cost of the device really low. On the left side, you see we added an application CPU, which is running the I/O because the Powerline chip itself doesn't provide real sufficient input and output objects. It is a communication chip. It is not a microcontroller which is designed to run industrial I/O applications. On top you find, for the HD-PLC CPU, you find the different software stacks running the HD-PLC communication with IP, UDP, TCP, and on top of that an HTTP server, SSL, TLS, all you will expect as a standard. We are having drivers for the UART, and we implemented Fieldbus stacks on top of that, both running IP, running on serial, and this is agnostic against the protocol. So we did that for LON, we did that for BACnet. You can imagine a Modbus TCP, Modbus RS-485 gateway, or even KNX, DALI, all of that. So we have that all on the roadmap to do that. So the Fieldbus stack is running independent on the user application, on the application CPU, which makes it very robust. So the application CPU cannot kill the stack. That's very important. On the other hand, the user application cannot kill the HD-PLC behavior because that's very time critical. That was the method we have chosen, and it is really very robust. We provide a development kit for that, having pretty tiny breakout boards with 12 inputs, outputs, analog and digital, and it's protocol independent, so you can implement your LON or your BACnet application. So that was the add. The CTA-709.8, it is approved. I just had a look again at the CTA homepage. It is 85% complete still. The estimated complete is now end of February due to some meetings, which is still faster than we do in the European Union. We have 28 countries. No, we have 27. We lost Great Britain. And yeah, most likely in the April meeting, we will have a final approval in Europe. Let me put that 709.8 to the orchestra of the 709 standards, because I need that later for the BACnet slides. So we have all the different 709 standards from the protocol behavior and a couple of physical layers defined. And if we have a look how that matched together with the 7-layer OSI model, see, okay, well-defined 709.1, that's a stack, 709.1 and 5, that's the presentation with NVs and messages, 709.6, snippets, functional profiles, skip-its, all of that. And we have a huge bunch of physical layers, now 7 standards available. RF I put already inside. 709.10 will be the web services which talked in the morning about. And so Lonmark is doing a huge effort in making the protocol independent on the transport layer. Transport layers are more or less implemented in hardware. software implements the protocol stacks, and we have a couple of different implementations for the stack. Adesto just will announce in a few days together with us at Landmark that there will be a tiny protocol stack running Cortex M3 CPUs. We have some details in 709.8. We will have a master device which is spreading the messages to the node. Normally it's identical with the HD-PLC master. All devices know their master because the master collects the information from the network, and only with the master needs to have a unique IP address. We implemented aggregation. Who is using HomePlug or something like that? Powerline communication at home? Nobody? So powerline communication at home is normally used to stream data, audio, video, internet downloads, and so on. It is not that good in making a ping pong request response. So it's streaming like TCP/IP is streaming, and all the guys being so old like me, I remember there had been no delay parameters in TCP to make it usable in the industrial application. So what have we done at first in addressing? LON has a unique feature. You can have group addressing. Group addressing is not really mappable into IP. We have multicasts, which are not that liked by the system administrators, but HD-PLC does not really like multicasts between devices in the topology. So if we have a group addressing, we send the message to the master, and the master spreads that as an IP multicast to the nodes. That was the first constraint we have to fix because of some performance limitations that spread spectrum technology will have. The other one was we had to implement aggregation. So if a device is sending some messages in a given time, we combine that into a single message. So we aggregate that, the others do the same, and they send that again to the master. And the master again can combine all of these messages, if some came too late, with the second one, and sends that back to the devices. Devices are already in the market. So the first device really doing something is from Vossloh Schwabe. This is a street lighting company. They have a HD-PLC based auto luminaire controller, taking all of the advantages of high speed, long distance communication. We have it at the booth 1227 in the demonstration, and we integrated that auto luminaire controller into the LONWorks control networks. We have our development kit. We have a bridge device from LON IP to HD-PLC LON, which acts additionally as a master. It can bridge Ethernet and RS-485. It connects to Adesto Smart Server, you will see that, and we can use that for our own router too as an entry into the HD-PLC world. And we are working on BACnet for HD-PLC. So you have seen in some slides before, it is only a piece of software we put on the HD-PLC chip. Simplify that, it is BACnet IP, which is running on HD-PLC without having switches and on the longer distance. It can substitute MSTP. MSTP is a nightmare regarding reliability, regarding collisions, token loss, and so on the RS-485 network. And you can even reuse the existing wiring, MSTP wiring, to run HD-PLC on that. So it can boost your performance in the BACnet network. So this is a little bit similar to the LON world. You see we have lower layers in BACnet, which refer all to the same NPDU messages. In the past we had a LON layer, which was mainly used by Siemens. We have with 709.7 the opportunity to tunnel BACnet IP messages, UDP messages on a free topology network, and the blue one is new at BACnet. That's a secure communication model which is once again tunneling NPDUs of BACnet through a WebSocket connection. So similar, not that as detailed as we have in LON, is a 7-layer OSI model, physical layer, data link, transport, and application layers. So how does HD-PLC fit in here? The first approach is pretty simple. As HD-PLC is tunneling Ethernet, we can use natively BACnet IP on HD-PLC. So it's a usual IP link which is transferring UDP. You don't even need to have a BACnet router from BACnet IP to BACnet HD-PLC, because that would be just a media converter like that. The other thing which is actually evaluated in parallel is to make a generic HD-PLC BACnet frames, once again transporting the NPDUs. That's not pretty ready, but the first prototype is already running. So on our evaluation board, we made a device with smart actuators and smart sensors. You need to have a device object, some of the sensor objects. This is what we put inside of the object definition for the device objects. As a sample, binary input object. So we walk through all of the painful object definition if you are making code for that. That was the first time I really loved LONWorks again after a long time, because using Node Builder is much easier compared with implementing a BACnet device. And it works already. So you see that this is a BACnet analyzer from a German company we are related with, from MBS. They're running a test lab. The sibling company is running a test lab nearby, and so our BACnet IP implementation on HD-PLC is already running. Our pretty little device will work as a media converter from BACnet IP to HD-PLC, or as a native router, either what implementation method will be chosen in the future. We will join the BACnet Plugfest in May 2020 in Germany. There we will add our development kit with running the smart sensor and smart actor profiles, and with a DIN rail bridge. LON doesn't have Plugfests because LON is a technology which ensures interoperability much better compared with BACnet. So in BACnet we have different stack levels. I think we actually have BACnet stack version 14, which is not that interoperable with older versions. We can tunnel RS-485, which is once again more or less a no-brainer. I've seen that RS-485 is still something about 10% market share in buildings here in the US. So old technologies, the dinosaur of automation is still alive. There is no big asteroid killing it. It will survive, I think, in the next 50 years too. I will die with having Modbus surround me. Modbus has a lot of difficulties. You have grounding issues. You have a limited number of devices per trunk. You have a limited length of the wiring. And you come over all of that restrictions using HD-PLC to tunnel that. You can implement free topology, long distances, and you can even do something which is pretty cool. And the different trunks, you can use different baud rates. If you are tunneling RS-485 on, let's say, something like Ethernet, it's dependent on the gateway letting out the RS-485 again, which baud rate you have. So it's even if all of the devices talk with each other, I made the smart server IoT from Modesto, the master. The different trunks can have different baud rates. You never can do that with the standard Modbus installation. So yet another trick to solve some problems. If you want to put some other Fieldbus systems on HD-PLC, there are some key factors you have to obey. If it is IP-based, It is quite simple. We have already KNX IP in the market, Modbus TCP, some proprietary, but most of the protocols you are dealing with are serial protocols like DALI, especially proprietary, and you have to address latency. HD-PLC has a latency of about, if you have maximum hops, number of hops, of about 20 milliseconds. So when I've been talking about RS-485, what you can't do is tunneling BACnet MSTP via HD-PLC. That will never work. We don't tunnel handshake signals on HD-PLC. That won't work. If you are working on IP, you have to deal with the message sizes. They shouldn't be too small because then it becomes inefficient. And you have to deal with unicast and multicast addressing. So that are the key aspects if you want to port yet another Fieldbus system on HD-PLC. At the end, I have collected some aspects for building automation using HD-PLC. HD-PLC at first boosts your performance, and it is saving costs because you don't need new wiring. You can use the existing wiring. And one of the most underestimated issues is if you are changing wiring, if you are changing the fire load of your building. Who is dealing with fire load? No? Okay. If you are changing fire load, you have to update the documentation of your building. You have to recertify your building with fire brigades, all of that. So it can be a real issue if you double or if you introduce new wiring. You have to take care. You have to open the separation of the different parts of a building, keeping the fire away from each others. HD-PLC can run in parallel with existing installations, so it's an easy migration possible if you use it on twisted pair or coax. If it runs on the power cables, it does not need new wiring, and it brings your communication wherever you need. So in Europe, my company, we are actually addressing gas stations to boost the performance between the pump and the point of sale system. You have seen that already in the first slides I showed. If you want to boost the performance between a pump and a point of sales, normally you have to pull new cables between the pump and the shop. And on a standard petrol station in Europe, there's a cost of about 27,000 euro because the ground is sealed. If you take that, it is about 1,000. That's a cost saving. Okay, that's it. I'm in time. So thank you. Thanks once again from Michael, who is in bed. He's fevering, unfortunately, and especially from me for joining the presentation. We have questions.
So hopefully no Corona anything there. Any question from Matthias over there?
Yeah, what does the development kit, is it available?
Matthias, could you repeat?
Yeah, so the question was, what is the approximate cost for the development kit and is it available? Yes, it is available. I have them on stock and it is around $2,800. Any else?
Perfect, excellent. Well,
yeah, I just want to invite you again. Go to our Longmark booth, 1227.
1277.
1277. Okay, yeah, 1277. So there's a multi-protocol demo running, which is not only HD-PLC, of course. It is BACnet on free topology. It is Modbus RTU. All of that combined and put together with a smart server IoT. It's a great demo. It's the most beautiful demo we had in the last years. Thanks to all who had been working on that.